At the end of the topic, you will be able to define a set, represent a set in different forms, identify different types of sets. Welcome to the topic on sets. Let us first define a set. A set is a collection of all well-defined distinct objects. Here are a few examples for well-defined sets. For example, states of India, different types of quadrilaterals. Describing a set. There are three different ways to represent a set. Roster form. All the elements are listed and are separated by commas and are enclosed within curly brackets. For example, A is equal to 3, 6, 9, 12, 15. Descriptive form. Representation of set in words. A is equal to set of all multiples of 3 between 0 and 15. Set builder form. A set defined by stating the properties which its elements must satisfy. A is a set of all 3x such that x is greater than 0 and less than or equal to 5. Element of a set. The objects present in the set are called elements of a set. If the object is present in the set, then it belongs to or is an element of the set. If the object is not present in the set, then it does not belong to or is not an element of the set. Consider the set given below. Here, car belongs to A and van does not belong to A. Null set or empty set. A set which has no elements is called null set or empty set. It is usually denoted by either of these symbols. Given below are examples for empty sets. Singleton set. A set which has only one element is known as the Singleton set. Example, set of women presidents of India. Set of numbers which are neither prime nor composite. Cardinal number of a set. Number of elements in the given set A is called cardinal number of a set A and is denoted as n of A. Cardinal number of a null set is 0 and singleton set is 1. Consider the following sets. A is equal to 1, 2, 3, 4, 5. B is equal to null set. C is equal to A. Here, n of A is equal to 5. N of B is equal to 0. N of C is equal to 1. Finite and infinite sets. Finite set. A set which contains countable number of elements is called a finite set. Example, members of a family. Infinite set. A set which contains uncountable number of elements is called an infinite set. Example, set of sand particles in beach. Equal sets. Two sets A and B are equal if and only if every element of A is an element in B and every element in B is an element in A. For example, in the given sets A and B, the birds in set A and set B are same. Hence, given sets are equal sets. Equivalent sets. If the cardinal number of the given sets is equal, then the sets are equivalent sets. Consider the two sets. C is equal to 4, 5, 6 and D is equal to 7, 8, 9. The cardinal number of the sets is the same. Therefore, sets C and D are equivalent sets. Equivalent set is denoted as shown. Subset. The set M is a subset of a set N if all the elements of M are also the elements of N. It is denoted as shown. Set of integers is subset of set of rational numbers. Every set is a subset of itself. Null set is a subset of every set. Superset. Consider these sets A and B as shown. Here, every element in B is an element in A. Therefore, B is the subset of A. In other words, A contains every element of B. Hence, A is the superset of B. It is denoted as shown. Proper subset. Let A be the set of Indian cricket team and B be the set of all-rounders. B is said to be the proper subset of A if B is contained in A and A is not equal to B. Symbolically written as shown. Improper subset. A is the set of Indian cricket team and B is the set of Indian cricket team. Then, A is an improper subset of B if A is contained in B and A is equal to B. Symbolically written as shown. Power set. The collection of all subsets of a set is called the power set. If a set has n elements, then the number of subsets is 2 to the power n. If the given set is A, the power set is denoted by P of A. For example, consider the set A of 2 cars. Then, P of A is as shown here. Universal set. A universal set is a set which possesses all the elements for any specific discussion. It is denoted by U. In numbers, the set of real numbers can be considered as the universal set since it contains rationals, integers, whole numbers, irrationals. Does the following pair represent equivalent sets? A is equal to the set of all even numbers less than 10. B is equal to the set of odd numbers less than 10. Click on the solution button to view the solution. At the end of the topic, you will be able to define Venn diagram, represent sets and its types and the operations in sets using Venn diagram, elucidate the properties of union and the intersection of sets. Venn diagram. The method of representation of a set in the form of a diagram was introduced by the mathematician John Venn. Therefore, such diagrams are called as Venn diagrams. A simple closed figure is used to represent a set. Given here are a few representations of a set. Universal set is usually represented by a rectangle. Disjoint sets. Two sets A and B are said to be disjoint if they have no element in common. Overlapping sets. Two sets are said to be overlapping if they have at least one element in common. Set operators. The following are the basic operations involved in sets. Union of sets. Intersection of sets. Complement of a set. Difference of sets. Click on the respective button to view the definitions.
Now look at the union of two sets. The union of two sets A and B is a set containing the elements of A or B or both. Union of two overlapping sets A union B is a set of all X such that X is an element of A or X is an element of B or both. Union of two disjoint sets A union B is a set of all X such that X is an element of A or X is an element of B. In this case, the set A union B contains all the elements of A and all the elements of B.
Let us now see the intersection of two sets. The intersection of two sets A and B is the set of elements which are in both A and B. Intersection of two overlapping sets. The intersection of two overlapping sets A and B can be expressed in the set builder form as A intersection B is the set of all X such that X is an element of A and X is an element of B. Intersection of two disjoint sets. When two sets are disjoint, A intersection B is a null set. Let us look at the complement of a set. The complement of a set is the set of all elements in the universal set that are not in the given set. If A is the given set, then the complement of the given set is denoted by A dash. Thus, A dash is the set of all X such that X is an element of U and X is not an element of A. Let us now look at the difference of two sets. A difference B denotes the set of all elements in A but not in B. Thus, A difference B is the set of all X such that X is an element of A and X is not an element of B. Similarly, B difference A denotes the set of all elements in B but not in A. So, B difference A is the set of all X such that X is an element of B and X is not an element of A. Here is what we mean by symmetric difference. The symmetric difference between two sets is the union of their differences and is denoted by delta. Thus, A delta B is equal to A difference B union B difference A. Here are the properties of union of sets. Commutative property. A union B is equal to B union A. Associative property. A union B union C is equal to A union B union C. Law of identity. A union phi is equal to phi union A is equal to A. Idempotent law. A union A is equal to A.
Here are the properties of intersection of sets. Commutative property. A intersection B is equal to B intersection A. Associative property. A intersection B intersection C is equal to A intersection B intersection C. Law of identity. A intersection U is equal to U intersection A is equal to A. Idempotent law. A intersection A is equal to A.
Let us now have a look at an example. Find the symmetric difference between the sets A is equal to A, B, C, D and B is equal to A, E, I, O, U. Click on the solution button to view the solution. Here is the next example. For the given three sets, verify that A union B intersection C is equal to A union B intersection A union C. Click on the Solution button to view the solution. In this topic, you have learnt union of sets. A union B is the set of all x such that x is an element of A, or x is an element of B, or x is an element of A intersection B. Intersection of sets. A intersection B is the set of all x such that x is an element of A and x is an element of B. Complement of a set. A dash is the set of all x such that x is an element of U and x is not an element of A. Set difference. A difference B is the set of all x such that x is an element of A and x is not an element of B. B difference A is the set of all x such that x is an element of B and x is not an element of A. Commutative and associative properties are true in both set union and set intersection, but not true in set difference. Union distributes over intersection.
At the end of the topic, you will be able to apply set operations and Venn diagrams in solving problems.
Let us now see the properties related to the set operations. Let A and B be two sets. Phi is a null set and mu is a universal set. The symbols for union and intersection are as given. A union B is equal to B union A. A union A is equal to A. A union phi is equal to A. A union mu is equal to mu. A intersection B is equal to B intersection A. A intersection A is equal to A. A intersection phi is equal to phi. A intersection mu is equal to A. A union B union C is equal to A union B union C. A intersection B intersection C is equal to A intersection B intersection C. A union B intersection C is equal to A union B intersection A union C. A intersection B union C is equal to A intersection B union A intersection C. De Morgan's law. A union B the whole dash is equal to A dash intersection B dash. A intersection B the whole dash is equal to A dash union B dash. Phi dash is equal to mu. Mu dash is equal to phi. Let us inspect some formulae in set theory. For any two finite sets A and B, where n denotes the number of elements, n of A plus n of B is equal to n of A union B plus n of A intersection B. For any three finite sets A, B, and C, where n denotes the number of elements, n of A union B union C plus n of A intersection B plus n of A intersection C plus n of B intersection C is equal to n of A plus n of B plus n of C plus n of A intersection B intersection C. Now let's look at an example to understand sets in a better way. If A is equal to B, C, D, E, B is equal to A, B, C, C is equal to E, F, verify that n of A union B union C plus n of A intersection B plus n of A intersection C plus n of B intersection C is equal to n of A plus n of B plus n of C plus n of A intersection B intersection C. Click on the solution button to view the solution. Venn diagram. Venn diagram is the diagrammatic representation of sets and the operations in sets. It is a tool that fosters comprehension of sets. The Venn diagrammatic representation of some sets and set operations are given. Click on the respective Venn diagram button to view the Venn diagram.
Representation of set operations using Venn diagrams. Here are some representations of set operation in Venn diagrams. The shaded regions represent each of the following set operations: A union B whole complement, A intersection B whole complement, A intersection B complement, A complement intersection B, A complement, B complement, A complement union B complement.
Let us now look at another example. An elocution competition was held in Telugu and Hindi. Out of 108 students, 57 students took part in Telugu, 51 in Hindi, 18 in both Telugu and Hindi. Find the number of students who took part in Telugu but not Hindi, who took part in Hindi but not Telugu, who took part in either Telugu or Hindi, and who took part in neither. Click on the solution button to view the solution.
Example: from a survey of 100 college students, a marketing research company found that 75 students owned stereos, 45 owned cars, and 35 owned cars and stereos. How many students owned either a car or a stereo? How many students did not own either a car or a stereo? Click on the solution button to view the solution. Here is the next example. Shade the following set operations using Venn diagram. Click on the solution button to view the solution.
In this topic, you have learnt: for any two finite sets A and B, where n denotes the number of elements, n of A plus n of B is equal to n of A union B plus n of A intersection B. For any three finite sets A, B, and C, where n denotes the number of elements, n of A union B union C plus n of A intersection B plus n of A intersection C plus n of B intersection C is equal to n of A plus n of B plus n of C plus n of A intersection B intersection C. Venn diagram is the diagrammatic representation of sets and the operations in sets. It is a tool that fosters comprehension of sets.